Hello everybody, and today we're going to be doing another tutorial on basically how to solve an ordinary differential equation, but when you solve for the auxiliary equation, you're going to be met with complex roots, and we just want to find the general solution for that. So, there's now three things that happen. When you just want to solve any homogeneous linear second order differential equation, you either get 1a, you either get two distinct roots. That is definitely not right. Two different roots. You get two different roots. You either get a double root, or it could look like r minus 3 squared. That's what I mean by double root. Or you get 1c, which is a complex root. Complex roots, which is usually two roots. And basically, when it's this equation, it's going to be complex roots. So let's do that first. So when we solve for auxiliary equation, remember that auxiliary equation is of the form r squared plus br plus c is equal to 0. Here a is equal to 1, b is equal to negative 8, and c is equal to 20. So r squared minus 8r plus 20. We solve. Actually, since we can check if this is going to be a complex root by just doing if 4ac minus b squared is less than 0, then we're going to have a complex root. So let's check that, right? 4a is 1, c is 20, b squared is going to be 64. 4 times 20, actually wait, maybe I'm doing this wrong. Is it b squared minus 4ac? Oh wait, I think it is this. Is 64. That'd be greater than 0. Am I doing that right? Or is it b squared minus 4? I think it's b squared minus, yeah, no. It's b squared minus 4ac. Yeah, and if this is less than 0, yeah, this is 64 minus 80, and that's less than 0. So, when that happens, there you're going to solve for the roots in a different way, which I think is a little quicker way, but it's kind of like a shortcut method. So we're going to solve. So first, we know it's going to be complex roots, right? So our general solution is going to look like this. C1, let me go like right here. It's going to look like this. C1E alpha times t. This is all times cosine beta t plus C2E alpha t sine beta t. So all we have to do is just solve for alpha and solve for beta. And the way we can do that is by this. So alpha is just going to be the opposite of b over 2a, and beta is just going to be the square root of 4ac minus b squared over 2a. So I'm solving for alpha. Opposite of b is positive 8, and then that's just 2. We get that alpha is 4. Beta, it's just going to be the square root of what? 80 minus 64 divided by 2. B is going to be 16. Square root is 16 over 2, which is just going to be 4 divided by 2, which is just 2. And so now R1 is going to be alpha plus 2i. And then R2 is just going to be 4 minus 2i. We really don't need these roots. All we worried about is just alpha and beta. So our final answer is just going to be, I'm going to write this in bright green. E for t cosine 2t There we go. And that is our final answer. We'll do one more. So let's solve another one. Our next question is going to be 2y prime minus 2y prime plus 25y is equal to 0. So first, what you can do, even if it wasn't a complex root, this is going to be a complex root, but we can check if it's going to be a complex root by doing b squared minus 4ac. And if this is less than 0, then it's going to be a complex root. We see b squared, b here is negative 2. This is going to be positive 4 minus 4 times 2 times 25. And this is for sure going to be greater than 4. So we know this is just going to be negative. So let's find our auxiliary equation. It's going to be 2r squared minus 2r plus 25 is equal to 0. We can do our normal thing where we solve for alpha, which is going to be opposite of b. B is negative 2, so opposite of b is going to be positive 2 divided by 2. It's going to be 1. And beta, square root of 4ac minus b squared over 2. And remember, our roots is just going to be alpha plus or minus beta I, but we don't have to worry about this. You can probably use this for some other type of questions, but just for our purposes to solve for alpha and beta, that's all we need, right? So let's solve for beta because we know alpha is 1. Beta, actually, let me erase this because we really didn't need that. Okay, so b is going to be equal to the square root of 4 times 2, which is 8. 8 times 25. 8 times 25 is going to be 200. It's going to be minus 4. Divide this by 2. B is going to be the square root of 196 divided by 2. And we can just do 196 divided by, I think, I'm not sure what this, actually, maybe, yeah, I'm bugging. And the square root of 196 is just going to be 14 over 2. This is just 7. So, we know that y of t is going to be equal to c1 e t I didn't edit it, oopsie. This should be times 2. So this is going to be 1/2. And this is also going to be times this. So this ends up being just 7 over 2 instead. So we'll reset this, and then now we get C1 is E. And yeah, this is our final answer. Honestly, the hard part about just solving these type of equations is just the algebra, and honestly remembering this formula right here. And this isn't C1 either. this is going to be C2. There we go. And yeah, we can do, we'll do one more. It's going to be a little different. I'm going to be using u this time. So let's find the general solution of u prime plus 10u is equal to 0. So we can, here, what we actually could do is we can actually solve u plus 10. Wait. Take out u, this becomes u plus a, not plugging. Right, first let me change this real quick. It's gonna be r squared plus 10. Yeah, this is gonna be what's happening. R is just gonna be negative 10. R is gonna be the square root of negative 10. R is going to be the square root of 10i. And if we remember, root is going to be a complex root. It's going to be alpha plus or minus bi. Here, b is square root of 10, right? So, and here, since this is missing, alpha is missing, we know that alpha is going to be equal to 0. So, y of t is going to be c1 e0 times t cosine square root of 10t plus c2 e0 times t cosine. Both of these e's are just going to go to 1. And then our final answer, c1 cosine square root of 10t plus c2 . This is our final answer. Thank you for watching, and yeah.